7.3 is the absolute value equations. So what we're looking at here is solving these equations. So if we have, oh, and this didn't copy in here, so if we solve the absolute value of x is equal to 2, so that value that we could put in there to give us an answer of 2 or a solution 2 could be a positive or negative value. Because remember, absolute value is measuring a distance. How far is something from 0? So to be 2 from 0, you could be 2 to the negative, or you could be 2 to the positive. So x could be positive or negative 2. And that's because the absolute value of positive 2 is 2, and the absolute value of negative 2 is 2. So steps for solving the equation, or an absolute value equation, there's 3 basic steps that you follow. The first one, just like radicals, is you want to get that absolute value by itself. So have that on one side, and everything that's not in the absolute value should be on the other side. Once you've done that, then you set up your 2 cases. You have a positive case and a negative case. So as you can see in the example, our answer could be 2 or negative 2, so we have to do that. And then you solve for each case, and then the last thing is to check to see if you have an extraneous solution. So we're going to solve for the absolute value of x minus 2 plus 3 is equal to 9. So our first step there would be that we would move that 3 over. So if we subtract by 3, the solution that we're looking to solve is x minus 2 is equal to 6, because I would subtract 3 from both sides. So I look at both the positive case and the negative case for this. So the positive case would be that x minus 2 is equal to 6. So that would be x is equal to 8. And the negative case would be x minus 2 is equal to negative 6. So if I add 2, x is equal to negative 4. So when I do my check, I have to check both of them. So I check 4, x is equal to 8. So I do my left side, right side. So my left side of the equation was the absolute value of 8 minus 2 plus 3 equals 9. So 8 minus 2 is 6. Absolute value of that is 6 plus 3, so 9 is equal to 9. So that one worked. So now I check for negative 4. So my left side, right side. This is the absolute value of negative 4 minus 2 plus 3. So this is the absolute value of negative 6 plus 3. The absolute value of negative 6 is 6. 6 plus 3 is 9. So it works. So we could solve this as well by graphing the equation. So if I started with absolute value of x minus 2 plus 3 is equal to 9, and what you did in the other sections there, we put it so that it was in that PQ formula, right? APQ formula. So that means I would bring my 9 over. So I would have absolute value of x minus 2 minus 6 is equal to 0. So then what we want to do is we want to graph y is equal to the absolute value of x minus 2 minus 6. So my vertex here, I've got my a is equal to 1, p is equal to 2, q is equal to negative 6. So my vertex is at 2, negative 6. A is equal to 1, so it's a basic count. So up 1 over 1. So over 1, up 1, over 2 2 up 2 over 3 up 3 and so on. And then once I graph that, I find where my x-intercepts are. So where does the graph cross the x-intercepts? So vertex is at 2, negative 6. So 2, negative 6 puts me right there, and then I do my over 1 up 1, over 2 up 2, over 3 up 3. Oops, I missed that one. And then I keep going. Oops, not very straight, but you can get the idea. So I have an x-intercept at 1, 2, 3, 4, 5, 6, 7, 8, right there. And I have one which should be right there at negative 4. So my x-intercepts are negative 4 and 8. So that means that my x is equal to negative 4 and 8, which is what I found by solving the equation. So the next example, we're going to solve the absolute value of 3x minus 2 equals 1 minus x. So we're going to solve it algebraically. So I have the absolute value by itself, so now I can do my positive and negative case. I don't need to move anything over. So my positive case is just going to be that equation dropping off the absolute value sign. So 3x minus 2 is equal to 1 minus x. So if I add x and add 2, I have 4x is equal to 3. So x is equal to 3/4. So now for my negative case, I have 3x minus 2 is equal to the negative of that, so it's the negative of 1 minus x. So that's the same as saying 3x minus 2, 3x minus 2 is equal to negative 1 plus x. So now I do the same thing, just solve for x. So if I move my x minus my x, add my 2, I have 2x is equal to 1, so x is equal to 1/2. And then you do your checks. So if x is equal to 3/4, do my left side, right side. So absolute value of 3 times 3/4 minus 2 is equal to 1 minus 3/4. Need my absolute value sign there. So I have absolute value of 9 over 4. I'll make this so it's a common denominator. So if I have a denominator 4, that makes that 8 over 4. And this side will equal 1 minus 3/4 is 1/4. So 9/4 or minus 8/4 is a 1/4 absolute value. So that one worked. I try it for 1/2. So I have absolute value of 3 times 1/2 minus 2. My right side is 1 minus 1/2. So 3/2, absolute value of 3/2 minus 4/2 is equal to absolute value of negative 1/2, so that's 1/2. 1 minus 1/2 is 1/2, so that works. So then my solution, and you should always write your solution out, I didn't do it in the last one, but x is equal to 1/2 and 3/4. So clearly identify it as your solution. Absolute value of x plus 3 sorry, keep mixing up my signs. X minus 3 plus 7 is equal to 4. So this, to get my absolute by itself, x minus 3 is equal to negative 3. So I subtract by 7. So my positive case is just to write it without the absolute value sign. So x minus 3 is equal to negative 3. So my negative case then is x minus 3 is equal to the negative of negative 3. So x is equal to 0. And on this one I'll have, if I add 3, x is equal to 3 plus 3, so it's a 6. So if I check this, x is equal to 0. So I have absolute value of 0 minus 3 plus 7 and 4. If I have negative 3, absolute value of negative 3 plus 7, so that's 3 plus 7 is 10, doesn't work. So that means that is an extraneous root. If I do x is equal to 6. So 6 minus 3 plus 7 equals 4. 6 minus 3 is 3, plus 7 is 10. Doesn't work. So this one then has no solution. So looking at no solution ones, if we were to graph this one, so this equation here, this would be the same as saying y is equal to the absolute value of x plus 3, and then if I move that 4 over, it would be 7 minus 4, so that would be a positive 3. So then that means your a is a 1, whoops, 1, p is a negative 3, and your q is a 3. I did it again. That should be a minus in there. So x minus 3 plus 3. So that means the vertex for here is at 3, 3. So my vertex here is at 3, 3, and then I'm doing over 1, up 1, and so on. I don't have to do a whole lot of these because you can see that this is above the x-axis, so it's not crossing the x-axis. And if you look at our equation when we manipulated it, we had y is, or not y, we had x minus 3 is equal to negative 4. This here is a hint that you're not going to have a solution. That's no different than if we had done the square root. If you remember from last unit, x minus 3 is equal to negative 4. This had a no solution because you can never have a square root equal a negative number. So if you have on one side an absolute value, and that's on one side of an equation, and on the other just a negative constant, then you will have no solution. Okay, and I think at the bottom of your page, it's on the bottom of mine, you had, it says example solve, and it might not be there, but absolute value of 4x minus 5 plus 9 is equal to 2. So when I go to solve this, I'm going to have absolute value 4x minus 5 is equal to negative 7. I subtract 9 from both sides. So this is a no solution because I have absolute value on one side, negative on the other. So that makes for a no solution. I'm just going to pause for a sec.